This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello, everybody, and welcome to a new episode of our Industrial AI podcast. My name is Robert Lieber, and it's a pleasure to talk to
Peter Sieber. Good morning, Robert. Good morning, afternoon, evening, all of you listeners. Welcome.
Welcome, Peter. Good morning. We have a lot of snow here in Franconia, so I'm sitting in my office, and I was happy to reach the office because the streets are packed with cars, so there was a huge traffic jam. So yeah, snow is heavily snowing here. Yeah.
Oh, really? Oh, no, that's different here. So I'm closer to the Alps.
Yes.
Where maybe typically it will be the other way around, I guess, right? But we have had, I must say,
Exactly.
we've had like 6 weeks of minus degrees here. Very untypical.
Okay.
So we talk about the weather changes, and we've always talked about, I think the last 10 years we didn't have any real snow, any real cold time. But
Exactly.
now everything seems to be back to normal. I don't mean that pun
Yes.
intended. It's,
But there's a difference between climate and weather. You know that, right?
so, yeah.
Yeah.
I guess so. But I heard somebody else say, because I think maybe not specifically, but in the area where you live there, schools are closed, and then people
Exactly.
are saying that's a bit weird. I mean, because normally we have snow here, we have cold times, and we shouldn't be closing schools for that reason.
Absolutely. I'm with you. I have 4 kids, so you know what's happening in my home.
Well,
Yeah.
Imagine.
But let's talk about snow, because we were in Amsterdam, and there's also a lot of snow. But when we arrived in Amsterdam, there was no snow.
Yeah, I saw this picture for whatever reason. I'm not sure. Well, every now and then I do see, I get like information by Google elsewhere I'm not sure about. And there was this plane, and the plane was moving over the landing area in Amsterdam to get rid of the snow. I hadn't heard of it, and that was only, I guess it was about a week, 10 days before we came. When we landed, everything seemed to be fine, right?
Yeah, everything was fine. No snow. A bit cold, but it was great in Amsterdam. So would you like to share some thoughts about Amsterdam, AI in Amsterdam, first time?
Yeah, most certainly. For me, of course, it was great to be back in my home country. I do try to get back to Amsterdam. I have tried, let's say the last 10 years, at least once a year to visit Amsterdam. It's not my home city, although I did spend a time in Amsterdam. I studied in Delft. It's not too far away. I mean, they call it the Randstad. Well, the Randstad is like a combination of the cities there, of Amsterdam, Rotterdam, Delft is kind of in between. And it is being considered many times as a huge urban conglomerate, right? So yeah, for me it was great to be there, to be welcomed, and at the same time also welcome our guests to Amsterdam. It was great. For me, I mean, this is actually the place where you're supposed to be asking what I thought was the best presentation or the best theme, and then I would typically say, "Oh, I don't have one." And as is typical, what I loved most is to be at the university. So they have built a separate building, right?
Yep.
Which they call what? Robotics and.
Lab 42.
That's the Lab 42, right? Oh, yeah. And the 42, I assume, is referring to a specific answer to a specific question from one of the stage Hiker's Guide, I guess, right? Yeah. So that's so nice. I love it. I love it when, like the same way here in Munich, I go to the TUM, to the Technical University. It's been some time now, but I go there, and it's so nice to be amongst people, young people, typically most of them, with their teachers, with their professors, and it's a wonderful environment. I love it a lot. That's what I really enjoy.
And it's very interesting because in Amsterdam, they combine research and entrepreneurship in one building. So you have startups in the third floor, you have research in the fourth floor, and you can rent there some offices. And I heard that some of our participants are planning to rent an office there for their people and to hire some people in Amsterdam after our trip there. So it's very interesting, very modern, very open-minded. So they work closely together, the startups and the researchers. So that was, for me, the first wow. I was very impressed by that. But then all our topics were very hot topics, I think. Yeah.
Yeah, right. I agree. I was also I was not confused. I was surprised maybe because, and I don't know the university landscape that well, but I think in cases where we have it, and just to stay with the example of Munich, I think north of Munich now, Tom, there's a big city kind of developing. So there is a combination of research and moving research into companies. Although, having said that, I think that's always been our missing link. Where in the United States, as an idea, maybe the same in China, I don't know, other places in the world, they seem to have been a lot better at moving research into applicability. So that's happening here, but it seems to be a lot more divided now, at least divided in buildings. So there's like a university building, and maybe across the street, then there are companies who then maybe, so they cross the street to be working together. And as you said, here it's within one building, and people have the same rest areas. They sit together, they work together. That was very impressive.
Let's come back to our topics. We talked about robotics, world models. We talked about world models in general. We talked about sim to real. We talked about scaling. Can you give us a little bit an overview? What was your main takeaway?
Well, my main takeaways were that I was really almost astonished that it seems, and with the specific terminology of cyber physical systems, and they seem to be back. And I said, Oliver Nigeman, and you listeners, Robert, we've talked with Oliver, and Oliver was there. Maybe he was even number one or number two, 6 years ago. And Oliver, as a professor now at the University of the Armed Forces in Hamburg, he's been doing cyber physical systems for, as long as I recall. And there was a point where I thought, oh, well, where's cyber physical systems going? And then in our session with Stratis, he came up with the term because we were discussing physical AI. And everybody's discussing physical AI, right? What did we say? Of course, the people that did not come to Amsterdam, they went to Davos. That's another place. But I think Amsterdam was a lot more important.
More research driven in Amsterdam.
And then everybody's doing physical. Everybody is talking. And I said, well, it seems many of the guys have been eavesdropping into the areas, the rooms where we were. So cyber physical systems was one, and symbolic AI as well.
I want to add something to cyber physical systems, because in our group we discussed that there's a second wave of IoT with robots, because the assumption is that you need a new communication layer or an existing communication layer between the robots and the machine or component, maybe like dishwashers or something, so that there's a interaction between the robot and the machine or the components. I think that was very interesting. So maybe an MCP like, I don't know, layer, I don't know, but something like this. So it was very interesting.
But the interface, and I was not, and that's what we typically do, right? So when we split up in this case, so this was kind of let's say the smaller version of the big AI in the Alps or the one that we do in autumn. And we, that is Robert, split it up left and right. And typically Robert sits with one group and I sit with the other one. So I wasn't in this one. But I can only confirm, I mean, that's in the end what agentic AI is. I mean, the AI piece is the user interface into what sits behind. I'm completely convinced about that, right? So, I mean, as I've said, I'm using it now all day, more in a private, sometimes maybe moving into business. But when I say my wake word for the smartphone that is lying here, I talk, and that is the user interface, whatever that is. But it is, I believe it is typically for all of us today, it is some kind of, language model. And the language model needs to understand what it is that we want, and then needs to pass on to whatever is behind it. So I believe that is the level that goes on top. So interesting that you guys were discussing that.
Yeah, don't get me wrong. I don't want to have an MCP. So maybe MCP like something, right? So they are convinced that there must be a new layer. Let's see if there is a new communication layer, and we will see a second wave of IoT. Then we talked about costs for sure, and the industrial guy said, "Oh, we don't want to have a new device on the machine, a new communication layer that costs us 10 cents, and then when you scale it." So there was a interesting discussion. Yeah, what else?
Well, and the second big one was the integrating, symbolic AI. It was the other big thing. So there was symbolic AI.
Yeah.
Well, it's starting with symbolic, really. I mean, it's 1957. And I believe one of the rooms was called after the guy. Now I forget his name, but the guy who used the term artificial intelligence first. And that was the time for 10, 20, 30 years, and that was called symbolic AI. And then it was said, it's going to take us a week and then AI is, solved, right? And that didn't happen. And then the winters came. And there has still been a group of people, but a smaller all the time group of people continuing with symbols. And then we came to our more classical machine learning, and then we came to our layers, and then we've been doing AI in different ways. Then we moved to ChatGPT stuff, and now we were discussing, we need to combine, we need symbols, we need to. For the world models need to be dealing with symbols as well. So that was very interesting. And then you come to the neurosymbolic. So when you combine the new way of doing things with the old way of things.
Exactly. And I have a quote from Davos. There was a talk with Jan LeCun, and he's also now a startup entrepreneur. And he says, there was a quote out of his speech, and now the quote is, Jan LeCun says, absolutely none of the humanoid companies have any idea how to make those robots smart enough to be useful. So that's the quote by Jan. And it was funny because then Elon Musk answered the tweet and he said, yeah, he thinks if he can't do it, no one can do it. So it was very funny.
He like Elon or he like Jan?
He like Jan. So Jan also needs to sell something now. So he has now an idea how to really make them smart. But that's exactly the discussion we had, right? So world models, we are at the beginning. We are not in the middle. We are at the beginning, and there are some different concepts. And I found very interesting that Stratis and his team, they are not into this whole topic when it comes to scale and more data and data and data and data. So that you need some more understanding. And this is interesting because the typical US way is to scale with more data, give the model more data. And that's a different approach. Let's see which approach maybe is.
Is that the, at least OpenAI, I believe, is on that side, so to say. Not sure about the other guys, girls, companies, if they're all, but at least on the other side, there's Jan, I think very clearly, Demis, Google is very clearly there. And having said that, this morning I read that nevertheless, the OpenAI, they had a robotic activity, they closed it. a couple of years back, but nevertheless, that they have still, again, about 100 folks working in that department. So let's see where they are looking.
But a quick reminder, because now everybody is saying scaling comes at its end. I know a guy, and he said that, I think 2 years ago in Vancouver on main stage, and now everybody is going in the same direction. He said scaling's come to an end. The bitter lesson is over. So
really cool.
So maybe it's really over, and it never started when it comes to robots, but because you need really more data and data and data and data for robotics. Yeah.
Now, that's another topic that just pops up in my brain right now, is like, because I just did the recording with André Sagodi from Audi, and you're going to be hearing that a couple of weeks is the plan. Robert and I, we have this schedule. We move it every now and then, depending, but you're going to hear in the next couple of weeks. And that's about scaling, but it's a different type of scaling. So when we talk scaling, the one that you just mentioned, Robert, is that the more CPU we throw at the problem, at large language model, the better the solution we get out of it, right? That is what the bitter lesson has always represented, right? It is like we humans can be as smart as we would like to, and we are every now and then, and we come up with great algorithms, with new ways of doing things, with agentic, etc. And then your competitor doubles the CPU and gets more out of it than you, having been an intelligent human. That's what the bitter lesson is, right? And that's when we talk scaling in the area of models. Now, the scaling, just to be, it's not that important now, but you're going to hear in the next couple of weeks, and that's a different scaling. If within typically a big organization, you start somewhere with a use case, in this case is Audi, in one of their factories, and it took him probably 5 years, and that's what you're going to be hearing. And then the same use case has been scaled to, let's say, 100 factories around the world. So they are two different types of scaling. It just came up as we were discussing scaling as well in Amsterdam.
And I have one more topic from Amsterdam, because there's also a connection to scaling, because we always talk about the digital twin, right? So the digital twin of a machine, of a tool or something like that. And then there was Leonardo. He's a postdoc in the lab of Stratis Gaffis, and he says maybe sometimes a digital cousin is enough. So, for example, when you have a cup, and we will record an episode on this topic, because I think that's very interesting, not to have a full digital twin, so that you have a digital cousin of an object. So you do not need all the information. You only need to know what kind of thing is it. Is it a cup with a handle, or is it a cup without a handle? So it's very interesting to talk about the digital cousin, I think.
I think that's where it moves into symbolic, I believe, right? Yeah. I mean, it's like the thing standing in front of you, call it a cup or call it, or whatever the elements are that you relate to the thing, with or without the handle, the collar, etc., etc., etc. And then a lot of that. And I think we discussed it last time in our news section, that there was this guy from one of the Fraunhofers who came up with a similar other idea, where I said, well, and then you move into Opus UA. That's very similar. Well, it is. I mean, it's information modeling, right? It's saying like, what is then the cup? Does the cup have a temperature? Does it have a pressure? Et cetera, et cetera,
exactly.
Et cetera. And
then we talk about physical AI.
I guess so, yeah. The only thing that we didn't do, and we had discussed maybe as we first talked about going to Amsterdam, is we didn't go into the canals, right? We need to do that next time.
Oh, yeah. Yeah, we will repeat it. I'm pretty sure we will come back to Amsterdam or to Paris or to Zurich. We will do that again, because the feedback of our participants was so good that, they were very happy. And it was very heavy, deep research, I would say. So it was deeper than our typical other events
that we've had before. Yeah, I would agree.
Yeah, but they really liked it. I remember Michael from Boysen. He was absolutely fascinated by the guys, what they do there in Amsterdam, and the discussions. And Werner from Aarburg also, he was very impressed, I think. Yeah, we will do that again, Peter. I think we need one deep research class every year in the beginning of the year. I think it's a good idea.
Yeah, that sounds like a wonderful thought. Yeah, let's see where we're moving, and then we're going to decide if we're going to. As I recall, we started with the weather, and as we discussed at that time we discussed Amsterdam, and we said, let's do something on a canal boat in the evening. And then we were at least I had it exactly in my brain. I thought, oh wow, but there's going to be like snow and it's going to be really, really cold. And I believe that was our thinking. My thinking at the time, we thought, oh yeah, you can't do a canal. And as we came there, it was a little bit. It was not as cold as where we are here, but and the canal boats were just moving around. Maybe not as many as normal, but there you go. So thank you very much to Stratis and his team, Leonardo, Christian, Andre.
Thank you very much to Stratis and his team, yes. And thanks to all our participants. As always, it was a great event also for us. You coming back home, and I discovered a bit Amsterdam. So yeah, it was very, very good.
I finished with, although I'm not a big football fan, for those
is it football or is it soccer?
They said I was sleeping in the room where a very famous Dutch soccer star, Johan Cruyff. I mentioned him yesterday to my German friends. They called him differently Cruyff. I think that's how they pronounce it.
That's a German way to pronounce
and
him.
I'm not a big football guy, but when I was a kid, yeah, he was the number one. I think even on a global level, he was there. So it seems the place where we were must have been like some kind of hospital, at least a baby giving birth to babies place, and that's where Johan Cruyff was born. So there you go.
Mm-hmm. And the next stop is AI in Amsterdam, first week of July, as always in the beautiful mountains of Lech am Arlberg in Austria. We can announce that Sepp Hochreiter is doing one session, Marco Huber is doing one session, and the third session is under investigation, I would say. So we will give you an update in the next 2 weeks.
Yeah, I think there's enough topics. Those of you that are interested, there's 2 ways. If you're already part of it, you can just say, yes, I'm coming. If not yet, you go through some kind of screening. But nevertheless, if you are interested and maybe you want to share with us your topic, there's probably 10 interesting topics that Robert and I, we need to agree which one we're going to be choosing. I thought you mentioned, did you say AI in Amsterdam? You meant AI in the Alps, right?
I meant AI in the Alps. Oh, I'm sorry. Sure. Oh, sorry. No, sorry. AI in the Alps.
Yeah. But we're talking AI in the Alps.
Yeah, AI in the Alps. So I'm really confused this morning. So AI in the Alps in Lech, first week of July, 2.5 days. Very nice surrounding, very nice people, a lot of interesting discussions. And then to complete the whole thing, AI on the volcano in autumn.
In autumn, right. And we'll go with the details later on.
Exactly.
Okay, well, that's it, Robert. Thanks. Have a great day. Enjoy the snow. Talk to you soon.
Thank you. Bye-bye.
Thanks. Bye-bye. Okay, and just as an add-on, Robert suggested during our news section that they in their group discuss an additional IT, OT, IoT layer. You refer to MCP. What a coincidence! In the main section, I will be talking to John Harrington. John is the co-founder, chief product officer at HighByte, and John and I will be talking about MCP services for industrial AI. So, and enjoy the talk I had with John. Today I'm going to be talking to John Harrington. He's the co-founder and chief product officer at HighByte. And John and I are going to be talking about MCP services for industrial AI. Hi, John.
Hello, how are you, Peter? Thank you for having me on.
I'm great. Amazing. I'm going to share that with our listeners, John. We just found out that we already met each other, right? What did you say? We met about, is it 15 years ago that you and I were traveling around related to the OPC Foundation. You were with Capware, I believe.
Yes, it was probably close to 15 years. And OPC Foundation would do road shows and, of course, Hannover Messe. And those were interesting times.
Amazing. Yeah, we are going to be talking a little bit, just a little teeny tiny bit about OPC UA later on as well. This is not the OPC Foundation podcast. This is the Industrial AI podcast, but nevertheless. Oh, great. Well, we know already a little bit about you, John, but nevertheless, let's start with you, please, introducing yourself to our listeners.
So like you said, I am the co-founder, chief product officer at HighByte. Prior to HighByte, I spent about 8 years at Capware and then PTC after the acquisition, leading product management. And my entire career has been in technology for manufacturing, sometimes on the software vendor side, like I am now, and sometimes on the manufacturer side, but very much finding solutions, finding technology solutions for solving problems, making manufacturing companies more efficient, whether it's in the design area, product design area, the procurement area, or now the manufacturing area. So yeah, there's a lot going on and exciting, always exciting to work in the technology field, but apply it to manufacturing.
Very good. Why don't you tell us a little bit more about your current company, HighByte?
Yeah, so HighByte is a industrial software company focused on industrial data ops. So think of data ops as the foundational layer that allows orchestration and governance of data across your industrial systems, as well as up into your IT systems. So a lot of times we're moving data into the cloud, we're pulling information out of the cloud, we can be moving anything from OPC data tags to MES transactions to files from a camera or from inspection equipment. And in many cases, you need to curate that data. You need to contextualize that data before you deliver it to the target system, because many systems don't want individual bits and bytes of data. They want contextualized data sets that they're used to consuming. And so very much working kind of that bridging the OT and IT divide and moving data seamlessly across them and providing companies a software solution to manage and govern and secure that data as it moves across all your different systems.
Sounds great, and sounds a lot like where I've been coming from, and as you suggested, something at that time, and as I at that time was moving into a thing we called it industrial data intelligence. So it seems that we've been moving like similar directions.
Yes, you're moving in those directions on the German side of the world, and I'm moving in those directions on the American side of the world. And today we get to converge them together. Very exciting.
Exactly. Sounds like it. That's amazing. So today we're talking MCP services for industrial AI. We were going to meet at the beginning of the year. Now the year is a couple of weeks into the new year. Maybe some of us forgot. We're going to find out. I discussed with my co-producer, Robert, what are going to be the topics, and we said MCP. Well, let's see. It was a big thing, maybe from the beginning of last year to the end, and we said, well, let's see what's going to be. So today we're going to be talking MCP. As a starters, remind us, what is MCP? What can I do with it?
So MCP stands for Model Context Protocol, for one. It was created by Anthropic. I think it was created it came out in 2024. So it's about just over a year old because it was near the end of 2024. And the uniqueness of MCP is that it was designed to work with LLMs. And LLMs are all about, natural language communications, just like ChatGPT or Claude, where you can just type in your request and it comes back. Well, MCP was designed for interacting with LLMs, for getting access to data and delivering that to the LLM. So the LLM can make a request over MCP, and then it can get back the data that it needs.
Right. Now, I've been asking, and we're going to get into more details later on. I've been asking from the very beginning what that means for such a protocol. We don't call OPC WAY a protocol. We always were told that that's an architecture. We're going to get into the details later on. But I always had this big need for understanding how these then would be working together. And as I said, you can give a quick intro, but maybe we're going to get into more detail there later on.
Well, I think one thing that I could add right now is if you look at OPC, it provides you the data. And if you look at, what that data looks like, it looks just like it looked on the PLC with that structure and with that naming convention. Similarly, if you look at MQTT, the same thing, you've got the data. And then if you look at like a REST API and, you look at how do you work with those, a lot of times you've got XML payloads or JSON payloads that are moving across APIs. But those were really all designed for computer systems to interact with, not for humans. But an LLM is really simulating human language. So what you want to do with an LLM is that you want to put in descriptions. So with MCP, you have these concept of tools, and tools are what you use. So you could have a tool for querying Pi or for getting certain OPC data tags, but that tool would have a description, and it would say, I'm the tool for getting access to data tags, and what you need to do is give me the tag name, and I'll give you back the current value. And so that's in a description. So when the LLM is saying, well, what tools do I have access to? I just had a request to get this data value. The tool would say, oh, I'm the tool to get data values, and you identify the tag, and I'll go and get it for you. And so it's a much more natural language environment, and you can give it things like parameters, and it'll tell the LLM, these are the parameters that you need to give me. Do you want the current value or historical values? Do you want, whatever information you want, whatever the parameters are set up for that tool. So it's a much more natural way of interacting with it, as opposed to protocols of old that were designed for computer systems to interact with them.
That's a very good introduction. That's a very good start for my brain. We'll get into more details later on. Now, end of last year, you released HighByte Intelligence Hub version 4.3. I understand expanding support for agentic AI, another big topic on the factory floor. Tell us a little bit about it and what role, if at all, MCP plays therein.
It plays a key role, a critical role. So one thing that's important when people are looking at new technology or the addition of AI into technology products is, are they using AI to interact with the product, or are they using AI, or are they making the data available for AI? And so for us, we call that AI for data ops, which is how can we leverage AI to accelerate or make the system easier to use or allow it to scale faster. And then we have this concept called data ops for AI, which is how can we provide data to AI, in this case over MCP, to LLMs, such that they can be more efficient or effective and get access to the data that they need. So we provided tools with that release, with version 4.3, that support both of those. So for instance, we allow you via an LLM now to be able to go in and create what we call pipelines. So if you're integrating systems, for each integration path, for each flow of data going out, you create what we call a pipeline in the software. And that's a data pipeline where we identify what is the data that the input data, how do we have to transform that data, and then where are we sending it to, and at what frequency or event or whatnot. So now you're able to just go into a chat window and say, create me a data pipeline that takes this set of data and transforms it in this way and sends it to this target, and it'll just build that out naturally. It also allows you to look at this pipeline and tell me what it's doing and then tell me, how has it been running? So really integrating AI into the product so that people who are less familiar with the configuration and less familiar with the product can easily find out what's going on and leverage AI. So that was the first area that we added to, and that uses MCP to interact with the LLM. The other area that we added was the data ops for AI. And with data ops for AI, we recognized a couple of things. So we had an MCP server in our previous release. We had released it, so version 4.2. One thing that we started seeing is a lot of other applications were adding MCP servers. And one thing that's important when you get into technology is to realize what technology does well and what it doesn't do so well. And it turns out with LLMs, you don't want to give them 50 or 500 tools. You want to give them a small number of tools that the LLM is very specifically focused on, or the agent. We call these agents now. So each agent works best when it's very focused. So how do we recognize that a lot of other applications are creating all these tools, but now the agents are going to be overloaded with tools and don't know when to use what, and that's where you see things that we commonly refer to as hallucinations, where the agent goes in the wrong direction. But if we can give it, these are the 5 tools that this agent can use, then it can be much more accurate. It'll use the right tool and it'll be able to deliver the right data and whatnot. So we added an MCP client that allows us to connect to other MCP servers, bring in those tools, and then we can deliver to the agent the exact tools that it needs. We also added, we extended capabilities. We're constantly refining how we're working with MCP in the product, just so that it, works better and whatnot. So MCP is like that critical interaction with the agents.
Very good. Now, you talk about MCP clients, MCP servers. The terminology sounds a lot again like the good old days of OPC UA. Now, is that correct for me to say, do clients and servers within the MCP world work in a similar way as does the OPC UA client and the OPC UA server?
Yeah, they're obviously different. Otherwise, we wouldn't need MCP. But there certainly is a client server component to it, where the client is what we call the application that's making the request. And in many cases with MCP and with LLMs, we call those agents. So the agent makes the request, and that's the client. And then the server is HighByte's software, the intelligence hub, which takes that request, and then we can fill it with data from any system that we're connected to.
Both the client, the MCP client, as well as the MCP server are HighByte, or do understand that other companies would provide MCP service as well, that your client, which is then at some point in time your customer's client, could connect with as well.
Yeah, so we have 2 MCP clients in the product today. One is an agent for doing that pipeline configuration, and the other is the client to connect to other MCP servers, so we can aggregate those tools and provide a much more curated experience to the agent. But then, primarily we're an MCP server where we're serving up the data to the agent, consuming it from other applications. So for instance, we could put together a MCP tool that actually pulls data from your MES system, your Pi historian, current data from your OPC server. Or we could put together 3 different tools, 2 different tools, one that pulls historical data, one that pulls current data, but both of them also get data out of the MES system. One of the things that we find is that context is very important to data when you're moving it around, especially when you're crossing the OT to IT divide. And that context is often in other systems. So for instance, process context is in the MES system, while if you're doing asset maintenance as a use case, a lot of times the asset maintenance context is in the CMMS system or the asset maintenance system. So a lot of times you have to combine data from different systems together in order to give the LLM and the agent the accurate, a fully contextualized data set.
And that's what you can do, as you said, within your MCP server.
Yes, within our product, and then we can expose it as an MCP server. Yep,
Right,
yep.
right. That's what you sell to your customer, and your customer will take what they consider as relevant context information into their server, and then internally or externally, whatever they want to provide within the MCP server, that's what they then can make available.
Yes.
Now you mentioned context, and you refer to MES. And when I hear context, first thing again that I think of is OPC-UA. So I think of the OPC-UA information model. So it's like already like metadata. So instead of XY_342 somewhere, I can read as a human, and there you go. That's interesting, because now maybe then the LLM can read it through MCP as well, that this is really a whatever temperature of machine 23 in the back corner of building 23, etc. How does that work together? Is that when you say context, and when you say, do you also include then the meta information that is typically being provided by OPC-UA servers? How do those servers work together then?
Yeah, context is a term that's widely used and probably not well defined, but and the reality is context is in the eyes of the consumer, and context is in the eyes of the use case that it's being consumed for. And what we see is that context, depending on the use case, you need to contextualize data differently. If you're just moving it to the SCADA system, then adding context around like unit of measure and what is the user consumable name for that data tag. So maybe it's stored as a Modbus register or something on the PLC, and when we show it in the SCADA screen, we want it to say pressure, and we want to identify that it's for this pump, and we want to give it a unit of measure. But when you move it up into the process domain, where you're looking at, well, what is the average pressure for this batch, then you may also want to know what batch you're working on and what the product is and things like that. And what is the range that we want to keep it within. And that data is probably not on the PLC. It's in the MES system. Or were there any alarms captured while the batch was being pumped? So a lot of times you have to go, if you're doing process type stuff, then you want to go to the MES system and get information. If you're doing maintenance things, you may want to know who's the vendor of that pump and when was the last time we serviced it, because you're looking for what are the spikes and what's causing these spikes. You also may want to know what's the product that's moving through the pump, or what is the batch that we're working on. So you want to get context from different systems depending on the use case that you're trying to solve for. And that's one of the things that we saw as the PLCs have, OPCA Foundation has enabled them to standardize the naming or like at least put logical names on them, and they do have this, the modeling and whatnot. But when you move up the stack in terms of the use cases and the people that need access to the data, you often have to add additional context. And sometimes it's even to the point where you want to run aggregations or you want to calculate for certain metrics. You don't want the raw values, you want to calculate for certain metrics. And that's just a higher level context that people need as they're trying to solve for this. And of course, if you're moving it into a data lake, you also need to identify what's the site and what's the location and what line is this. That data is often not on the PLC. It's often in other systems. So
elsewhere, yeah. Now, moving up the stack is what you said. That triggers a question which I was going to ask one way or the other anyway. It's like this. We've always been discussing like the different levels of what is that? What is that hierarchy? What is the term for it?
Yeah, the ISA 95 Purdue model.
That's the official one, I guess. and it's and it moves up a certain level. And in the past, there was OPC weight, just as an example, relatively high up. Now I want to understand. So should we consider maybe understanding the way, if I understand correctly the way that you put it, now we have LLMs. Maybe we call them agents. Maybe they start LLM and then they are agents to access the information through MCP, which still today, but in the past exclusively, was a thing to be done for applications. Let's say for industrial applications, the industrial application would access an OpenCUA server. And if that's correct, does that mean that we're adding a level to the stack? So we're moving the stack more upwards by adding this MCP server capability?
So I don't think of it as adding a level. What I think of it as is the stack is really an application layer, set of layers. So you've got SCADA, you've got MES, you've got ERP, and of course the cloud adds more complexity to that simplistic model that we had, which was really kind of site focused and whatnot. But that set of applications are still in play. But where the challenge comes is that data needs to move separately. I think of it as data needs to move on a different dimension as that. So that's an application stack. You also need a data stack or a data movement layer that enables you to orchestrate data across that, because some data that the MES system may need, the SCADA system doesn't need. Similarly, the data that the predictive maintenance systems need, the SCADA doesn't need. And so instead of running it all up one layer after another and overloading the different systems, if you think of it as each layer needs access to data and has access to data, and we need to be able to seamlessly move across all of the layers. And that's a way that we really think of it. So we named our product the Intelligence Hub because it's a hub and spoke approach to moving data. We can connect to the MES system, to the ERP system, to the cloud, to a data lake, to your SCADA or even your OPC or like MQTT sensors. But we can seamlessly move data across them. And if one system needs access to data, we can pull it from whatever system it's located in, add any context or any curation to that data, and then deliver it. And in fact, like I had said earlier, a lot of times we're combining data from the OPC layer, from the SCADA layer, from the MES layer or the CMMS, and then delivering it to wherever it needs to go. We also do a lot of like pulling it out of the cloud and moving it back down into the HMIs on the factory floor. For instance, we have a customer who wants their operator to be able to know more details about the orders. Well, the order data is in SAP. In their case, they're actually moving that to Snowflake. And so we pull it out of Snowflake and we deliver it to the operator's terminal so that they can know, what is the quantity, who's the customer for these goods. So data moves seamlessly across, not just one layer to the next. It's really about moving it the most efficient way and delivering it as it's needed.
Okay, thanks. That helps me a lot, and I'm sure our listeners as well. I want to move towards get a feeling for a couple of use cases. We've been maybe relatively not too technical, but I do want to understand a little bit more. Like maybe you want to tell us in what markets that you operate, and then maybe share one or two typical use cases where you're using exactly the solutions that we've been talking about.
Definitely. So HighByte has customers really across all of manufacturing as well as like power and utilities. So we have anyone from an automotive OEMs to industrial products companies to consumer goods, to food and beverage, pharmaceuticals, steel, mining, oil and gas, and then some power and utilities and some water, wastewater. So really wide range of customers. What we see is, some of them have different system architectures in place. Some people, for instance, in the oil and gas space, we find a lot of people are using Pi as a historian or Aspen Tech, and they want to get that data out of those historians into something that data scientists can really dig in on and work with. So they may be moving that data into Snowflake, for instance. So they could use us to move that data into Snowflake so that they can start doing some analysis of what is our production, where are we seeing failures, how do we, where are we seeing success and challenges, and really driving various use cases around predictive maintenance as well as around just operational improvements. Similarly, we have a number of customers in the pharmaceutical area. With them, there's a lot of complexity around batch management and interaction with the MES system. The MES system needs a fair amount of data. They tend to be very complex. The MES system also produces a lot of data and has a lot of data. And again, they want to get that data out of the MES system and move it up into the cloud so that they can do analysis, so that they can report for traceability purposes, and so that they can report for regulatory purposes. So many different use cases. A lot of times it's how do I get data into different, people's hands that in the past had very little access to industrial data. So for instance, the quality team or the reporting team, the regulatory and traceability reporting teams, or the team that's looking at power consumption. In the past, all those teams really would get reports. A lot of it was paper. A lot of it was after the fact. Well, now, how do we get them access to data in near real time so that they can do their jobs more effectively and in applications that are designed to consume that? But what that ends up being is just a lot more data. And so they need them in solutions like up in the cloud or in Snowflake or Databricks or Amazon or Microsoft so that they can really work with and analyze that data.
So you could say, and I was going to ask that you brought me there, is the type of person, maybe in addition to what in the past was maybe typically the control engineer, maybe they would have even PLC programming capabilities, I don't know, and I'm sure they will still continue to do what they do. But can you say that in addition, we have another maybe type of person that in the past, as you said, was very passive? They got something, or if they really needed it, they needed to get always to go through a person that had access to the data. Can you say that today these people can now access also maybe including through natural language because they have an LLM in front of it, or maybe call it an agent, I believe you say, they can now be accessing, they can request what it is that they want and expect what they need?
Yes, exactly. And so what we're seeing is, like you said, in the past, the operator on the shop floor and the controls engineer would have access to data of what's happening on the shop floor. But that was really it. It was available through the SCADA, through the historian, if you had access to those systems. Now we can deliver that data to anyone that needs it in whatever system they're working with. So a lot of IT teams are designating a preferred cloud vendor, and they're building applications in that cloud vendor. And so, we can deliver the data to them. Or, as you said, with a chat interface or a chatbot, an agent, you could request that data. In fact, I was listening to your podcast with James from OpsMate, and they would be another consumer of that data. So they're building an agentic framework to be able to utilize industrial data and get you access to data, and they may have access to some of their own data. But if they need access to, say, the MES system or the ERP system, or they want to pull data out of certain cloud services, Intelligence Hub can be that. It becomes that data foundation to be able to deliver data exactly to where it needs to be. And that can be over MCP, or that can be over a proprietary protocol that one of the vendors may use and we have integrations to.
So you refer to preferred cloud vendors of your customers. So assuming your solution runs in the cloud, any ideas or already on the edge as well? How is that about inference close? Is there a necessity for it to, in addition or as well, run close to the shop floor?
That's a great question. I should have probably covered it earlier. So the software generally is run in the factory, on or near the shop floor. In many cases, it's moving data up into the cloud or pulling data out of the cloud. It can run in the cloud, and we have some customers that'll run it on the shop floor to collect the OPC data and the images and whatnot from the floor, and then they could have another hub running in the cloud that then provides that MCP access to the data to a cloud system, whatever that is. So yeah, it can run on either. We don't select cloud vendors. We can run on Amazon, Azure. You basically just spin up either a container or a virtual machine, and you would run the software. So the customer really owns the operation of our software. The advantage to them is that they have complete control of their data. There is a little bit of overhead, obviously, but they have complete control of their data by doing that. And a lot of times they'll also run multiple hubs within a site. And the reason that they do that is they have different network topologies and firewalls and moving data across different, the OT network, the IT network. And so they would very often have a hub in the OT network, another hub in the IT network, and then move it up into the cloud. So it's very open and flexible from that architecture standpoint.
Sounds great. Let's look a little bit into the future. What is this going to do? I mean, one way of looking at this is, as coming from technology, which, that's what you've been doing, I've been doing. But maybe there's the other thing as well. I mean, things changing globally. Maybe you look at the United States, I look Germany, Europe, around the world. Talking manufacturing and the issues we have today with not having maybe all the time the right people to do certain things, capabilities. What is this approach that you, including the MCP client service, for maybe an additional audience, so to say? What is that going to help? What is it going to help your customers in doing what they want to do? I mean, in the end, produce, and where they want to produce as well.
Yep, I think it opens up the potential. There's just a huge amount of potential to leverage data and to get access to data and to run your factories and your teams better. There's when we say factories, most people think of the operator, which is critical. But there's also all of the other engineering roles, the quality engineer, the maintenance engineers, the design engineers, the supply chain. They also need access to data. And what we're seeing, if we look into the future, how does agentic AI impact things? Well, if we roll back, in Industry 3.0, where you had a SCADA system and an MES, and maybe a historian, depending on the type of production you did, and those would be what needed access to the factory floor data. And that's where OPC servers really were born. And so, you would have maybe 1 to 5 consuming applications in a factory. And with Industry 4.0, we saw the cloud come on, and the big trend was to move data up into the cloud. But when you move data into the cloud, you don't want to just move it into one service. Depending on what the data is being used for, how it's being contextualized, it needs to be contextualized uniquely, and you need to deliver it to the service that needs it. So sometimes you're moving it to a data lake, sometimes to an MQTT broker, sometimes to an actual application that's running in the cloud over some API. So what we saw was probably a 10x increase in the number of consumers of data. So we went from 1 to 5 to 10 to 50. With this advent of MCP and agentic AI, we actually believe that it's going to balloon by a factor of 100 on top of Industry 4. And the reason for that is that agents are most effective if they're highly targeted. So for each work cell in a factory, you may have a quality agent, a maintenance agent, a supply agent that makes sure that the right supply is available for that machine to machine the parts that it's making. You may have a production agent. You may have an ops agent to interact with the operator. So agents really are highly focused reasoning models large reasoning models to help out in this way. And so as a result, what you see is we could have thousands or tens of thousands of agents that are reporting up to the humans, that are reporting up to the operator. Some of them will go to the operator, and some will go to the quality engineer, and some will go to the power engineer and give them the information that they need. So all of a sudden, we see this huge number of consumers of data, and they're everywhere. Some of them are running at the edge, some of them are running in the data center, some of them are running in the cloud. And somehow we need to deliver the right data to each one of them and be able to control the data flows to them. And that's really where we see the opportunity in the data ops space is, how do we deliver data to all these agents so that they can make all of the humans that are working with those agents, orchestrating those agents, become superhuman. And we just see a rapid growth of the need to orchestrate and curate high quality data, and then to be able to govern all of that.
And MCP playing a very central role in the picture you just painted for us, right?
Yes, MCP is critical for the interaction with agents. But like I said, so is OPC, because the way that we get that PLC data is through OPC. And the way that we get the MES data is either through SQL queries or through APIs. And the way that we get the sensor data is through MQTT. So it's not like one replaces the other. It's that each protocol is used where it's really good at. And where it's not so good or where it wasn't designed for, then we use another protocol. And the key is that you don't get hung up on the protocols. The protocols are just the way that we interact with the software. What's really important is the context and delivering the right data with the right context in the right way to that system. Less about the protocol.
Thanks, John. Let's come to a close here. Tell us a little bit more about your team or your company, people around you, where you're based. You told me at the very beginning before we started recording, maybe you're looking for talent in specific areas. If so, one or the other listener may be interested. If so, what should they bring?
Yeah, so thank you for that opportunity. So HighByte, we were founded in 2018. So that makes us, we're working on our 8th year. We are based in Portland, Maine in the United States, on the East Coast. So we're about 2 hours north of Boston. We've got people who work for us across the United States, very much many people who work remote. And so that's not a problem for us. We're designed, for that sort of environment. We work with distribution overseas. So we work with a company called Novatech in Europe and work very closely with them. We've been working with them since the very early days. In fact, I knew them back from when I was at Kepware. So they're a great partner of ours. And we have many other partners. We have partnerships with Amazon and Snowflake, and we have partnerships with system integrators and Databricks and Azure and Siemens. And so many, many companies. And we're certainly always looking for people. The best way to find out is to go to our website. Also, go to our LinkedIn and subscribe if you want to learn more about the product and the company. We've got a great website with lots of information, knowledge base, and whatnot. But we also have a YouTube page where you can see the software in action. And so reach out. We're always partnering with companies, looking for customers, looking for employees. So it's a constant thing. We're growing very quickly, and it's exciting times. Data is, I like to say data is becoming a first-class citizen. In the past, it was all about the applications. I think now people are recognizing that having a data strategy and really focusing on data products is important for companies. And so we're really excited about what's happening both with the cloud and all of that, with AI and all of that. And it's just, it's opening the doors for making our manufacturing companies so much more efficient and able to move faster.
John, thank you very much. You've been very helpful for me, and I'm sure for many of our listeners, painting a clarifying the picture in my brain of where MPC would sit. MCP, sorry, yeah,
MCP.
where MCP would sit.
Yeah. MCP, OPC, MQTT, REST. Someone will make a song out of it all, but right now, yes.
Yeah, that
MCP.
would be a good idea. That's a good idea. But as far as you're concerned, it's going to play it is already or will be playing an even bigger central role in making, if I understand you correctly, making the data available that in the past and still today, but in the past exclusively was available more, let's say, for a more technical audience through applications capable of understanding protocols, communication architectures, including OpenCUA, and then today make that available for humans that are maybe, less technical, but at least interested in the data, and in the past could only have them passively or needed to go through a third party. And now today they can go through their preferred LLM, which is then, activating agents and getting the information. Thank you very much for that. It's amazing. It's amazing. I was really surprised when you at the beginning said that we have met in the past. That's amazing to find each other back again this way through LinkedIn, actually. Thank you very much. Maybe we'll see each other somewhere here around the world in the United States. Maybe you suggest that you come by at Hannover Messe or any other place, or by visiting your distribution.
Definitely.
Thank you very much.
Yes. Well, thank you for having me on the podcast. And that was a great explanation that you just gave as to where MCP fits. I agree. It's in that area where you're pulling the data out for people who in the past didn't have access to it or didn't have the right access to it. It also makes it much easier to learn systems because now people can, configure them through MCP. So, the sky's the limit. We're all learning. It's changing quickly. It's evolving quickly, but it's exciting times. And, appreciate the time on your podcast and look forward to meeting you in person. Maybe Hannover Messe would be a great place for that.
Me too. Thank you very much, John. Take care. Bye-bye.
We'll see you, Peter. Thanks. Bye.